So to really dig into regression, we're going to look at a business decision in a very specific business context. In particular, what we're going to look at is the situation of competitor entry in a pharmaceutical market. In the pharmaceutical space, you tend to have a long development phase where you're not actually generating profits, but you're actually just expending money on research and development, following by the drug release, if all goes well, with profits and sales that follow, and eventually patents tend to expire. And so the question we want to ask is, what happens after that expiration period to your sales? In other words, competitors are now able to enter a market in which you previously were a monopolist, and we want to see what that's going to do to your business. So specifically, suppose you're asked to analyze the impact of a patent expiry on the sales and price sensitivity for a product, your own product. You're given sales and price information before and after the entry of a generic drug, so this is after the expiration of the patent. And your objective is to quantify the impact of this new entrant in terms of the amount of sales lost and the amount of change in price sensitivity, meaning the degree to which people's response to price may be different prior to and following competitor entry. So the two questions are, is there a significant drop in sales due to competitor entry? And is there a change in price elasticity or price sensitivity due to competitor entry? The data we have are weekly data, where we have the number of sales units per week, the price at that time, and whether competitors were allowed to enter. This is going to be represented as a dummy code, which is simply a 0-1 indicator variable, where 0 means no competitors entered in this market at the time, and 1 is after the expiration of the patent, where we have competitors in the marketplace. So let's jump right into our data set. And as we can see, it's pretty simple. There's only these 3 variables, because that's presumably the variables that you have access to as the company that's doing the analysis. Now, before we do anything sophisticated, it's generally a good idea to just look at some summary statistics. So for instance, let's take a look at the number of sales and the average price paid prior to and following competitor entry. And we can do this just by looking at the means. So we can go to Analyze, Compare Means, and we can say we want to look for sales and price as a function of entry. In other words, tell me the mean price paid and the mean number of sales at each level of entry. And if we do that, what we see is that the average number of sales prior to competitor entry was about 13,000, and following competitor entry was only about 4,000 or 4,600. So it seems like there's a big drop, but again, we're just eyeballing at the moment. We're not doing any statistical tests. And we also see that price went from about $5.26 to $6.45. So price actually went up after competitor entry, which is a little bit unusual. But it seems like there are at least these differences that we need to investigate. And the way that we do this is with a regression, where we say we want to predict sales in a particular period of time as a function of some constant, beta 0, plus beta 1 times d, which is going to be a dummy variable, which represents whether there was competitor entry or not. And the way that a dummy variable works is it's always going to be 0 or 1, where 0 represents the absence of something and 1 represents the presence of it. And in this case, it's going to be the presence of competitors. We're also going to have a random part of sales in period t, which we can't estimate. That's just going to be the error. And so testing whether the sales drop is significant is simply a test of whether the coefficient for the dummy, beta 1, is statistically significant. And so we can do this in SPSS. We simply go to Analyze, Regression, Linear. We want to predict the influence on sales as a function of entry, and we hit OK. And if we pop down to our coefficient table, what we find is that the influence of entry is negative 8,700 units, and it is highly statistically significant. That value is less than 0.05. And so we can conclude that the influence of entry on sales is negative. In other words, as competitors enter the marketplace, sales go down by 8,700 units. Now you may be asking, why do I need a regression when I'm merely testing the difference in means across 2 different categories, entry, no entry? And you're right. So in fact, we can do the exact same thing with a t-test. If we say Analyze, Compare Means, Independent Sample t-test, we want to know the influence on sales as a function of entry, and we need to define our groups. This time there's 0 and 1. And if we run that, what we find is that there is in fact a highly significant difference. And one thing to point out is if you look at the t-value, which is the degree of effect, how big this effect is, it's identical to what we found in the regression. They're both 5.12 in the absolute. What this tells you is that a t-test is actually just a special case of regression where we have a single predictor variable and that variable is a dummy variable. And what we'll see is most of what we're doing is actually just special cases of regression. The nice thing about regression is that it's flexible enough to let us do other things as well. One of those other things is something called multiple regression. This is where we can simultaneously put in multiple variables as predictors of a particular outcome. And what this lets us do is estimate the influence of any variable given some level of another variable. So let me show you an example in this drug sales dataset. If we go to Analyze Regression Linear, we still have the same thing from before. We have entry predicting sales. So if you recall, following entry, price also changed. So it's the case that two things may have simultaneously changed after entry occurred. One is that we have competitors, and the other is that the price changed. And we don't know if it's the price that's driving the sales effect or the entry that's driving the sales effect. But we can test those simultaneously by including price and entry simultaneously in our regression. If we do that, we find the following. We find the following coefficients. First, we find that the coefficient for entry is much smaller than it was before. It's only negative 1400, and it's not statistically significantly different from 0. However, we find that price has a very significant and very negative influence. In other words, it's not the entry of competitors per se that drove the effect on sales, it's the fact that it also happened to co-occur with a change in price. And the way to read this coefficient table is we say that the influence on price given a level of entry is this much. It's negative 6100. The flip is true as well for the other effect. We say the influence of entry is negative $1,400 given a level of price. Now that effect isn't significant, but we can still make a statement of that kind. This tool of multiple regression is actually incredibly powerful and lets us test really complex relationships and their influences on sales. What we'll look at in the next video is the second question that we wanted to address. It's the question of changes in price elasticity as a function of entry, and I'll explain how we do that in a moment.